Now we're going to begin working with solving radical equations. Sounds real tricky, but for the most part, it's not too bad. We'll go through the solving of like number 1. I'll talk about number 4. We'll go on to number 7. I'll show you how to do that one. We'll talk about the others. Don't get freaked out by these. These are the toughest of the group. And then you'll have some application problems. Now, I'm going to leave the application problems up to you guys. It is everything that you've done up in here. You've just got to be able to write this stuff and do what you're supposed to do to be able to solve it, to be able to solve the application. Now, after the application, you've got some nice review. Ooh, systems of inequalities over here. Ooh, some shading. Some nice review that's going to tie into what we're going to be doing next week called a final exam. So these are nice worksheets that have nice reviews of these problems. But I want you to work on numbers 13 and 14 really on your own. I'm not going to give you too much help with that and see if you can set them up, because that is where you can prove that you know what you're doing. If you can set it up into a radical equation that you're going to learn how to work with and then solve it from there, you're doing great. Now, number 1. The square root of 2n is equal to 10. I know I wrote it as 2x, but life goes on, okay? The square root of 2n is equal to 10. You can't have a radical in an equation. You've got to get rid of the radicals. And like all other algebraic equations, you learn how to add, then you learn how to do the opposite, subtract. You learn how to multiply, you learn how to divide. You learn how to do the squares of something. So now you learn how to do the square roots. But now they're giving you a square root. What's the opposite of a square root? The squaring of a number. So you've got to take this, because we need to get rid of the radical sign first. Okay, we can't have a radical sign. So you've got to take this to the second power. And take this. You've got to balance the scale. You've got to square both sides. Squaring something will get rid of the radical sign. How, you say? Let's see. Radical 2x times radical 2x. What is radical 2x times radical 2x? What is 2 times 2? 4. What's x times x? X squared. The square root of 4x squared. Well, what's the square root of 4? It's 2. And what's the square root of x squared? X squared, the perfect square of x squared is just x. Look at what happened. I took the 2x, radical 2x, and squared it. And what did it end up making? Just plain old 2x. Understand, that's going to be the same for all of these problems. If you square n minus 3, the square root of n minus 3, it's just going to make n minus 3. So don't get too worked up in showing this crap. All this crap is just proving that if I square a radical, it turns into whatever's inside the radical. Done. Okay? Now, I squared 10. What's 10 squared? 10 times 10 is 100. So now I've got to take and solve the equation. I've gotten rid of the radical. Now I can solve this by dividing by 2. And 100 divided by 2, x equals 50. Check it. Take the 50, put it in for the x. This turns into a 50. What's 2 times 50? Square root of 100. What's the square root of 100? Oh, it's the perfect square of, ta-da, 10. Works out nice and neat. Okay? Let's try I'm going to back up so you can see my garbage for this. I'm going to show you number 4. Get it started for you, and you're going to look at it and go, oh, okay, this is getting a lot easier. Okay, so let's check this out. Alrighty, number 4 says the square root of x minus 3 is equal to 6. The square root of x minus 3 is equal to 6. How do I get rid of the radical? I square both sides. The square root of x minus 3 to the second power is just x minus 3. I don't need to show you the FOIL method of x minus 3 times x minus 3 when you work this out. It's going to, suffice it to say, it's just x minus 3. Okay, just know, if you square the junk that's inside the radical, it's just the junk that's inside the radical. Now you've got to square the opposite side. 6 squared is 36. Now it's just a one-step equation. You can test this on your own to see if it works, okay? Test it to make sure it works. I'm going to erase this one because I just wanted to give you an idea of what happens with that. I don't want you just to use my work as your work because you've got to do these. But let's take a peek at number 7. The square root of 7x plus 2 plus 3 is equal to 7. What did they do to mess you up in this? They just added more crap. Understand, in a radical equation, you can't touch the radical until it's isolated, until it's just the radical equals whatever the crap is on the other side. Okay? So, just like an algebraic expression, you've got to get everything away from and isolate the x. In this, you've got to isolate the radical. So I've got to get rid of the 3. What is the opposite of a positive 3? It is a negative 3. And then I bring down my radical, which is 7x plus 2. Hey, look, it's just the radical now, and it equals 4. Now we've got it to a point like we did up here. You just have to solve the radical equation by squaring both sides. Square both sides. Now, how can we do that? If you do the same function to both sides, it's going to really just make the same problem times 2, or to the second power in this place. Okay? As long as you're doing the same thing to both sides of this equation, you're not changing anything. It'd be like this. If I had a 4x is equal to 20, and I multiply both sides by 2, it turns into 8x equals 40. Guess what? If I solve the original one, divide by 4, x equals 5. Divide by 8, guess what? X still equals 5. It didn't change squat in the problem. Just a little side note there for you guys to be able to get that in your back pocket for algebra. This little dealie here. Square root of 7x plus 2 to the second power is just 7x plus 2. And 4 squared is 16. Look at, you've taken the radical equation with junk on the side of the radical, isolated the radical, multiplied both sides, or taken both sides to the second power. Now it's just a two-step equation. Two-step equation. Subtract 2. 7x is equal to 14. Divide by 7. And x equals 2. Simple, simple, simple. But let's make sure that we're correct. Let's go back up to the original. Okay? Change the x into a 2. What's 7 times 2? It's 14 plus 2. What's 14 plus 2? 16. What's the square root of 16? You better not have said 8. Yes, it's 4. The square root of 16 is 4. Plus 3, does it equal 7? Winner, winner, chicken dinner. All right? Go ahead, work on radical equations. Don't get freaked out just because they have stuff on the outside like this one right here. 7 or 2 times the radical of n. Get rid of the 2. What's the opposite of multiplying by 2? Oops, jumped on you. What's the opposite of multiplying by 2? Divide by 2. Over here, you got to get rid of the 1. Over here, you got to get rid of the 4. You got to get rid of the 2. You got to get rid of the 5. Now, I like the ones. These are pretty simple. You'll get uglier, bigger, more crap to move around, but that's all it is. Just get rid of the stuff that's outside of the radical so that the radical is isolated, okay? Now here, you're going to have to try to isolate the radicals and the problems to be able to find the answer. It's not that bad. They give you some of the numbers. They give you some of the pieces to be able to plug into this and turn it into an equation. But don't freak out just because there's words. You guys are the gifted children, the special children. So these shouldn't be too hideous once you work on these. Now, if you have any trouble with the radical equations, let me know. I'll help you out. Talk to you later.